When you talk about wanting more power in your golf swing, I mean, the instinct is usually to look right at the upper body.
Oh, totally. It's completely intuitive.
Right, because you want to hit the ball harder, so you naturally focus on, like, swinging your arms faster, or you try twisting your torso with everything you've got.
Yeah, you watch the professionals on television, and you see that absolute blur of the club head at impact.
Exactly. And you think, well, that's where the magic happens.
But it creates a very powerful but misleading illusion.
How so?
Well, because you are physically holding the grip of the club with your hands, your brain just assumes the power generation originates there.
Right, it feels like a top-down mechanism.
Exactly.
But then you actually look at the biomechanics. I mean, you dig into what the longest hitters in the world are actually doing in three-dimensional space, and suddenly that entire top-down perspective gets flipped.
It really does.
The true secret to clubhead speed, like the actual engine of the golf swing, isn't in your shoulders.
No, it's not.
And it certainly isn't in your arms. It is hiding inside your shoes.
Yeah, we are looking at the absolute definition of a ground-up phenomenon here.
Which is why we're so excited to get into this today. Welcome to today's deep dive, everyone. We are exploring the biomechanics of the golf swing from the ground up.
It's such a fascinating topic.
It really is.
Yeah.
Specifically, we're focusing on the foot-ankle complex, ground reaction forces, and lower body kinematics. We've got a massive stack of sources today.
We do. We're pulling from some advanced biomechanical studies, research from the Titleist Performance Institute, and, some incredibly practical PGA professional coaching drills.
Yeah, our mission today is basically to decode the science of the lower body, cut through all that heavy jargon, and give you practical tools to hit the ball further and, honestly, more safely.
That safety part is huge.
So let's unpack this.
Yeah.
Why are the feet the most critical, yet somehow the most overlooked part of the entire swing?
Well, it comes down to a fundamental physical reality. Your feet are your absolute only physical connection to the earth while you swing. In biomechanics, we actually call that the closed terminal of the kinetic chain.
Okay, so the closed terminal is the feet.
Exactly. And the club head is the open accelerating terminal.
Hmm.
So power generation does not originate in your hands. It is initiated at the turf.
Oh, wow.
It's Newton's third law of motion in pure explosive athletic form. When you actively push down into the ground, the immovable ground exerts an equal and opposite force back up through your body.
And we refer to this as ground reaction force,
Yeah.
right? Or GRF.
Yes, exactly. GRF.
I'm picturing like a catapult here, or maybe one of those massive medieval trebuchets. Our sources actually lean pretty heavily on that exact analogy.
That's a really good visual.
Think about a trebuchet launching a boulder. If the heavy wooden base of that machine isn't firmly bolted to the ground, the throwing arm can't whip forward with any real speed.
Right, it would just tip over.
Exactly. The heavy moving parts, like the base, have to stop and aggressively stabilize so that all the potential energy transfers perfectly into the projectile.
And in the golfer's case, the projectile is the club head. Right. What's fascinating here is how highly skilled golfers optimize that exact stabilization mechanism.
How do they do it?
They utilize ground reaction force to create a highly efficient sequential transfer of energy. It initiates at the feet, moves up through the lower extremities, transfers into the pelvis, the core, the torso, out through the arms, and finally into the club head.
So it's literally a chain reaction.
Yes. If the base isn't stable, or if those heavy lower body parts don't brake correctly, the energy just leaks out into the surrounding air before it ever reaches the golf ball.
So how do we actually push into the ground to create that catapult effect? Because looking at the data we have, it's not just some chaotic jumping motion where you flex your knees and heave upward.
Oh, no, not at all.
The research outlines a very specific continuous flow of energy, a triphasic fourth pattern.
Yeah, it is a highly specific continuous biomechanical sequence. Biomechanists usually break this down into three distinct forces that happen in basically the blink of an eye.
Okay, what's the first one?
The sequence begins with the shift. This is the lateral ground reaction force. As you transition from the top of the backswing into the downswing, your pressure must shift toward your lead foot.
Right.
But the critical biomechanical requirement to make this happen effectively is progressive dorsiflexion.
Okay, let me make sure I'm visualizing this correctly. Dorsiflexion is the action of the shin bone rolling forward toward the toes, right? Decreasing the angle between the top of the foot and the shin.
That's exactly it.
Like, if my foot is flat on the floor and I push my knee forward out over my shoelaces.
That paints the perfect picture. That downward and targetward movement of the knee lowers your body's overall center of mass.
Okay.
By sinking into the ground while keeping the foot planted, you are eccentrically loading the massive muscles of your lead leg, specifically the quadriceps and the glutes.
Which is essentially like pulling back a heavy rubber band.
Yes, exactly like that.
You're stretching those muscles under tension so they store up potential energy. You are literally sinking into the earth to load the spring.
Right. But you can't just keep sliding your knees and hips forward toward the target forever.
Well, no, you'd fall over.
Right. At some point, all that forward momentum has to hit a wall. Which brings us to the next dynamic movement, the brake.
Okay, so the brake.
The brake utilizes rotational torque. That lead leg, which just loaded up all that kinetic energy like a stretched rubber band, now has to act as a massive braking system.
To completely halt your lateral slide.
Exactly. Your lead ankle aggressively transitions from that flexed, bent position into what biomechanists refer to as a stacked neutral alignment.
Meaning the joints line up on top of each other.
Precisely. The center of your hip socket, your knee, and your ankle stack perfectly vertical.
Oh, see?
Your leg becomes structurally aligned. It becomes passively straight. Not locked or hyperextended, but acting as a rigid pillar to stop your forward momentum.
And once that momentum hits that rigid pillar, it has nowhere to go but up and around, which leads to the explosive finale, the vertical ground reaction force, or the press. This is where triple extension happens, meaning the hip, knee, and ankle all extend forcefully at the exact same time.
You've got it.
Okay, wait, I need to pause and think about this for a second. To swing a golf club rotationally around my body, I actually have to push violently down into the turf.
Yeah, I know. It sounds incredibly counterintuitive until you factor in Newton's laws.
Right.
The ground is completely immovable. When your lead leg pushes down violently against that immovable surface, the surface pushes back.
Okay.
It creates a massive upward vertical force. That upward force travels directly into your pelvis, physically pulling your lead hip up and violently backward, away from the ball target line.
Ah, that makes so much sense. The downward push is what actually rips the hip backward and clears it out of the way.
That is the entire mechanism right there. That rapid, violent clearing of the pelvis creates a massive whipping effect.
Wow.
It pulls the torso, then the arms, and finally the club through the impact zone at maximum velocity. The arms become completely independent, acting like the end of a whip.
So if you don't push down to go up, your hips simply cannot clear fast enough to generate rotational speed.
100%. If you fail to push down, you lose the whip.
I am really starting to see why the arms are just along for the ride. But, you know, we can't just treat the foot like a flat block of wood during this process.
No, definitely not.
Because the foot isn't just statically pressing down. Our sources dive deep into how the foot is actually rolling and shifting in 3 dimensions to make all of this possible.
Yeah, the foot has to navigate an incredibly complex series of 3D movements to facilitate this energy transfer.
Right.
Let's go back to that transition phase we just discussed. You know, when you shift your weight laterally to the lead foot,
Okay.
as you shift, that lead foot actually pronates. It rolls inward, flattening the medial arch toward the turf. It does this by design, acting as a shock absorber for the massive lateral force of your body shifting toward the target.
But wait, if I just roll my foot inward with all my body weight accelerating onto it, something has to stop my arch from just completely collapsing into the grass, right?
Yeah, you'd think so. That protective job actually falls to the tibialis posterior's muscle.
The tibialis posterior.
Right. It runs down the back of your calf and under the arch of your foot. It acts like a parachute cord deploying behind a dragster.
Oh, that's a cool analogy.
It fires eccentrically to decelerate that inward rolling, stabilizing the arch and preventing the foot from collapsing under the lateral force.
Okay, I have to push back here for a second because this sounds incredibly sketchy.
How so?
Rolling the ankle aggressively inward, flattening the arch, shifting all your body weight while simultaneously swinging a steel club over 100 miles an hour. I mean, that sounds like a fantastic way to severely sprain an ankle or completely blow out a meniscus in the knee.
It does sound violent, yeah.
How does the human body survive this violent rotation hundreds of times around?
Well, the body has a brilliant built-in safety mechanism, provided the joints are allowed to move naturally.
Okay.
At the moment of impact and continuing into the follow-through, the lead foot rapidly does the exact opposite of pronating. It inverts and supinates. That's right. It aggressively rolls to the outer border of the foot.
So all the pressure shifts to the outside edge of your front shoe.
Exactly.
I actually see professional golfers do this all the time on television. Their front toe actually lifts off the ground and they finish balancing on the outside heel.
That visual is the perfect example of supination in action. As your pelvis rotates aggressively counterclockwise toward the target, your lead thigh bone, the femur, has to externally rotate.
Right.
If your lead foot remained glued perfectly flat to the turf, that massive rotational force would have nowhere to escape.
Oh, I see.
It would travel straight up the shin and twist directly into the knee joint, tearing the ligaments. Yeah. Rolling to the outside of the foot is a vital biological release valve. It bleeds off the excess rotational momentum safely, protecting the vulnerable connective tissue of the knee.
That honestly reframes everything. I always assumed rolling onto the outside of the foot at the finish was a sign of bad balance or like sloppy footwork.
Well, a lot of people think that.
But it's actually vital self-preservation, which brings up an incredibly logical consequence regarding what we actually wear on our feet.
Yes, the footwear.
If the foot must roll and supinate to protect the knee, then the structure of a golf shoe becomes a safety feature, not just a fashion choice.
The physical structure of the shoe absolutely influences this kinetic chain. The data shows that flexible, custom orthotics can positively influence balance and actually increase clubhead velocity because they support the foot's natural biomechanics.
That makes sense.
But surprisingly, the spike configuration on the bottom of the shoe doesn't seem to alter the frontal plane forces on the knee at all.
Really? Meaning it doesn't matter how aggressively your spikes grip the grass. If the internal structure of the shoe is rigidly locking your foot in place and preventing that supination release valve, your knee is going to take the brunt of the rotational torque.
Exactly. The internal mechanics and mobility of the foot inside the shoe are far more critical than the external grip on the turf.
Which leads us to a pretty crucial question. What happens when this entire kinetic chain breaks down?
It's not pretty.
Let's say I'm an amateur golfer listening to this and my ankles are stiff. I completely lack that dorsiflexion mobility we talked about earlier.
Well, when the closed end of the chain breaks, the entire golf swing deteriorates.
Just falls apart.
Pretty much.
Yeah.
Your nervous system knows the ultimate goal is to hit the golf ball. So if the ankles won't move correctly, the brain forces the body to introduce compensatory movements.
And what do those look like?
The most common and destructive compensations are early extension and swaying.
Let's trace the physical logic there. If my lead ankle can't dorsiflex, like if the joint is so stiff that it physically cannot bend forward to let the shin roll and drop my center of mass, then my shin bone just stays standing straight up, right?
Yeah. The tibia essentially becomes a rigid wall, but your upper body still has to shift its weight forward to strike the ball.
Right.
Since your knee is physically blocked from moving forward over your toes, your brain panics. To get your mass forward, it compensates by thrusting your pelvis straight toward the golf ball.
And that is the definition of early extension.
Exactly. Alternatively, the brain might just slide your hips laterally toward the target without rotating at all, which is swaying.
It's exactly like putting a kink in a garden hose.
Oh, that's a great way to put it.
The kinetic energy and pressure are trying to flow up from the ground, but if that ankle joint is locked, if the hose is kinked at the base, that energy can't flow smoothly. So it backs up and blows out the weakest point in the swing. In most amateur golfers, that blowout results in the hips thrusting forward, ruining their spinal posture and completely killing the space their arms need to swing freely.
It destroys your swing mechanics, but more importantly, it can physically injure you.
Yeah, the juries.
The data highlights a severe health warning here, which biomechanists refer to as the crunch factor.
The crunch factor. That doesn't sound good.
It's not. A landmark longitudinal study of elite golfers revealed that restricted lead ankle dorsiflexion is actually a primary biomechanical predictor of low back pain.
I think a lot of people just perked up at that. A stiff ankle at the bottom of the body directly leads to lower back pain at the top. Walk me through how those two are connected.
Think back to the vertical push we discussed, the press phase that clears the lead hip out of the way.
Okay.
If your ankle cannot flex, the hip becomes physically blocked from clearing and rotating internally. But your upper body is still swinging a heavy steel club at a high rate of speed. To force the club face to the target, the golfer compensates by over-rotating their shoulders and laterally flexing their lumbar spine.
So you are side bending and twisting the lower back simultaneously while swinging at top speed.
Exactly. That combination of twisting and side bending under load is the crunch factor. It subjects the delicate spinal discs to incredibly destructive shear stresses.
Ouch. I mean, that is the classic weekend warrior scenario right there. You wake up on Monday morning, your lower back is in complete agony, and you blame your mattress or your old golf clubs.
Happens all the time.
Meanwhile, the actual culprit is a stiff ankle that forced your lumbar spine to absorb all the rotational violence of the swing.
Exactly right.
So, now that we know the stakes, lost yardage, chaotic ball striking, and severe back pain, how do we test our own physical capacity? And more importantly, how do we fix it?
Well, the clinical gold standard for testing ankle mobility in this context is the weight-bearing lunge test, or WBLT. Yeah, it's incredibly straightforward to perform at home. You stand facing a wall, place a tape measure on the floor, and lunge forward, attempting to touch your front knee to the wall while keeping your front heel firmly planted on the ground.
So you simply slide your foot further and further back from the wall until you find the maximum distance where your knee can still touch the drywall without the heel popping up.
That's the test. And research has found a massive statistical correlation between a golfer's performance on that simple wall test and their downswing pelvis and shoulder rotation.
Really? Just from that test?
Yes, if you score poorly on the WBLT, your rotational velocity during the golf swing is severely physically handicapped. Your body literally cannot rotate fast enough because the ankle joint won't allow the hip to clear.
Okay, let's say I test myself this afternoon and my ankle is incredibly tight or my footwork is just slumpy and chaotic. Our sources provided some fantastic, highly practical drills to retrain these movement patterns.
They did, yes.
The first one is called the tripod foot. I appreciate this one because it requires zero equipment.
It's a brilliant coaching cue for establishing a neutral baseline.
How does it work?
At setup, you want to feel your weight distributed perfectly equally across 3 specific points on each foot: the pad behind the big toe, the pad behind the little toe, and the center of the heel.
Okay.
That is your physical tripod.
I love the sensory feedback of that. You just tap your toes and heels at address to ensure you aren't leaning too far out over the balls of your feet or sitting back heavily on your heels.
Right, it grounds you.
Achieving that 50-50 balance gives the ankle joints the freedom to articulate cleanly in all 3 dimensions the moment the swing begins.
Exactly.
But what about the dynamic movement? How do we train the brain to understand that shift and break feeling?
That is where the furniture slide drill proves invaluable.
Oh, this one is great.
You take a cheap, low-friction furniture slider, the small plastic discs you buy at any hardware store to move couches,
Yeah, I've got those.
and you place it directly under your lead foot. You take your normal setup, but position that lead foot slightly behind the trail foot.
So you are staggered.
Right. And then, as you transition from the backswing to the downswing, you make a practice swing where you physically slide that lead foot forward along the turf toward the target line.
I imagine doing this in a living room was completely ridiculous.
It might look ridiculous, but the neurological feedback is profound. The mechanical sensation is that your toes and the ball of your foot are actively grabbing the ground and pulling it forward.
Right.
According to Newton's third law, when your foot pushes forward against the slider in the turf pushes back. It creates a massive backward ground reaction force that forcefully pulls your lead hip backward, instantly opening the pelvis.
So you're not just thinking about opening your hips, you are creating a physical environment where the hip has no choice but to open.
Yes. It trains the exact muscular sequence you need.
That's awesome. And finally, to train that phase 3 vertical force, the explosive press, the sources recommend the stomp and turn drill.
The stomp and turn.
Yeah. The concept is that from the top of the backswing, you literally stomp your lead foot violently down into the ground and then immediately rotate your body through impact.
It's very effective.
I have to be honest, though. The data says this drill alone can add 4 to 6 miles per hour of club speed. Come on. Just from stomping a foot, I am highly skeptical of that claim.
It sounds exaggerated, sure, but the science supports it entirely. The stomp isn't magic, it's a neurological trigger.
Okay, how so?
Amateurs often spin their hips without ever applying vertical pressure. By aggressively stomping, you force the central nervous system to generate massive vertical force.
Right.
The immediate rotation then converts that vertical force into rotational clubhead speed. You are simply teaching your brain the correct timing of when to push against the earth.
Here's where it gets really interesting to me, looking at all 3 of these drills. Not a single one of them involves a traditional swing thought.
No, they don't.
They aren't about trying to contort your wrists into a specific position or holding your elbow at a certain angle at the top of the backswing. They are entirely focused on giving your body the physical capacity to allow a powerful, natural swing to happen subconsciously.
Exactly. You are upgrading the biological hardware so the swing software can execute efficiently.
That makes perfect sense.
If the hardware is broken, No amount of swing thoughts will fix the software glitch.
Wow. So distilling this mountain of biomechanical science down into actionable advice for your next range session, the modern golf swing relies on a sequential kinematic chain that starts deep inside your shoes.
Absolutely.
You must develop proper ankle mobility, specifically dorsiflexion, and sensory foot stability to allow for the shift, break, and press sequence.
That's the core of it.
If you want more effortless power, and if you desperately want to save your lower back from the sheer torture of the crunch factor, you need to stop obsessing over what your arms are doing in the mirror and start training your connection to the ground.
Knowledge is only valuable when it is practically applied. The ground is sitting right there, waiting to be used, and it remains the single most underutilized tool in the amateur golfer's arsenal.
So true. Well, if you enjoyed today's deep dive, please subscribe to our channel and share it with fellow golfers, coaches, and PGA professionals.
Yes, please do.
If there is a topic you would like us to research, analyze, and discuss in a future deep dive, feel free to send us an email or connect with us through LinkedIn. Whether your interest is golf, biomechanics, kinematics, ground reaction forces, swing mechanics, putting, coaching, club fitting technology, or sports science, we would love to hear from you.
We always love hearing your suggestions.
Our team will review your submission, conduct extensive research, analyze the available evidence, and may create a dedicated analysis, article, video, or testing project based on your topic. Thank you for being part of the eCoach 360-degree community.
As we wrap up, I want to leave you with a final thought to ponder.
Yeah.
We started today by talking about the hidden secret inside your shoes. Consider just how vital these complex three-dimensional foot motions truly are. The deep dorsiflexion to load the glutes, the pronation to absorb lateral impact, and the rapid necessary supination to protect the delicate ligaments of the knee.
It's a lot of movement.
It is. Given all of those biological requirements, what if the golf shoe industry's historical obsession with stiff, rigid, heavily spiked footwear is actually restricting the exact mobility our feet desperately need to generate power safely?
Oh, wow. Definitely something to mull over the next time you are sitting in the locker room lacing up for a round. Until next time.